It's important to notice that it was around 1980 when the debt started to skyrocket, which coincides perfectly with the fact that this was also the time when technology started to seriously expand, giving humanity the ability to make life better for everyone, if the technology would be used that way. To better understand our present social instability, we should review the principal physical events that have led up to our current mess. To help with this, let's establish a time reference. The two dates shown aren't specifically important, but just separate the timeline into three distinct regions. Now let's start adding vital information that will help you understand how we got to where we are in today's world. Prior to 1800, the world was a low-energy society. Why? Because throughout all recorded history before this time, the primary energy conversion machine for doing work was the human being, and a healthy human can only produce about 0.1 horsepower. In comparison, a washing machine motor is more powerful, averaging 0.5 horsepower. Regardless of this low power number, 98% of all work done during this time was a result of human labor, because humanity had not yet developed advanced technology to do the work for them. The other 2% came from sources outside of human muscle, which we will call non-human energy. The sources of this energy came from animals, like horses and oxen, and crude technology like windmills and water wheels. Because the human being is so limited, the output of his work is also limited. So no matter how many people you had on the job or how long they worked, they could never produce quite enough to cover growing populations or provide a high quality of living for everyone. If ever a few people did enjoy a decent standard of living, it was always at the expense of the many who barely survived. The fact is that throughout history, 95% of all people were either peasants, serfs, slaves, or indentured servants, even up through the time of George Washington. From the dawn of man until around 1800, the 98% of work done by humans and the other 2% by other means never changed. Ever. This is over 7,000 years of recorded human history with absolutely zero change in this dynamic. This caused every society on the planet to live in a social steady state, which means that there was no change in the rate of energy conversion at all. There was no fundamental change in how people worked to produce goods, and so scarcity prevailed everywhere. Now, just prior to the year 1800, a very significant event occurred. In 1782, James Watt developed the first steam engine. This invention was the beginning of an entirely new way to do work. It was the beginning of the widespread use of non-human energy, and since that time there has been an accelerated effort to build bigger, faster, and more efficient machines to convert energy into work. That effort has spread throughout the world, with the United States as a primary leader. Over the next 100 years, from 1800 to 1900, we find that the two energy lines started changing significantly. The non-human energy line moved up, and the human energy line moved down. In America, studies were done in the 1920s to see what social impact this change was having. Data was gathered on every basic industry in North America, charting the growth of production, the rates of energy conversion, declining man-hours, and the overall effects on employment. It was predicted that if the trends continued at the same rate, the lines would cross and look like this. Humanity was evolving from a low-energy society to a high-energy society as the two lines switched places. This new condition is the exact opposite of what had occurred all throughout recorded history, and that is no small change. Time to get a bit technical, so bear with me. As of 1992, noted by the U.S. Department of Commerce and Census, America had over 35.3 billion horsepower of installed prime movers. What does that mean? Prime movers are mechanical engines, turbines, and work animals, which originally convert fuels or force, such as wind or falling water, into work and power. Let's break it down by person. Prior to 1800, the average society had an energy conversion of just 2,000 kilogram calories per person. Does that number sound familiar? What is the calorie intake that is labeled on virtually every food item you buy? A 2,000 calorie diet. So it makes sense that if people are the primary workers, their energy is limited by their average calorie intake. Now back to 1992. 35.3 billion horsepower equals over 22 trillion kilogram calories, and the population of the United States was just over 250 million people. So in 1992, America was converting more than 89,000 kilogram calories per person of just non-human energy. That is over 44 times larger, a gain of over 4,000% as compared to the average society prior to 1800. This was a significant source of American growth and prosperity. We were the first and only country that was able to produce more than it could consume. Fast forward to today and consider these implications in our globally connected world. So what does the monetary system have to do with all this? The monetary system has started to falter over the past 90 years because the conditions of life on this planet have drastically changed. The two major requirements of the monetary system to survive, scarcity and growth, no longer truly exist. The globe has stabilized as far as growth is concerned, and scarcity has been eradicated by technology. As a result, we've experienced serious economic problems, and any solution that has ever been tried has served only as a patchwork solution of bubblegum in a cracking dam that is destined to break. No solution ever addresses the fundamental problem, because to do so would require a fundamental shift in our economic structure, and the people who have benefited the most from this system refuse to change the game. The surveys done in the 1920s covered every manufacturing industry, which were then plotted on charts. This chart is a summary of all those findings averaged together. The first line reflects physical production. From 1830 to 1900, production was low and growth was slow. Then we moved into a period of rapid growth. This was due to advances in technology and machinery and a greater use of non-human energy. From 1900 to about 1930, there was a spectacular exponential growth in physical production, at about 7% per year, compounded each year. However, this could not last forever, and a leveling off occurred. Now, let's add another curve to show what was happening to the man-hours per unit. This represents one person working 1 hour, regardless of their task. Notice in the early 1800s that man-hours were high, but then dropped as industry developed. This was inevitable, because it was cheaper to use technology versus people. A kilowatt-hour will do the work of 26 man-hours, but at a far less cost. The monetary system encourages businesses to replace costly manpower with cheaper and more productive technology in order to maximize profit. Now, from the 1980s onward, we have a unique situation that has never been present throughout the history of mankind. High production with far less human work needed. This would be great for everyone were it not for the interference of the monetary system, because labor is a major commodity that is bought and sold in the marketplace. Time for a third curve, which shows you what happens to labor and consequently what happens to purchasing power. This third curve represents total man-hours, the sum total of all time put in on the job in manufacturing by all people. As you can see, from 1830 to the turn of the century, total man-hours was low and the growth was slow. It followed the growth of production very closely, as they are directly related. Then it also grew along with production, but it didn't level off like production did. It reached a peak and then turned downward. This is an event that occurs in every industry. Total man-hours rises to an all-time high and thereafter declines. It is an event that occurs only once in any given industry.